2014 Lever Set High Level, Paper 1, Question 2 is a complex number questions. Let's add 1 equal 1 minus 2i. Obviously, we're told I squared is equal to minus 1 in all these complex number questions. The complex number z1 is a root of the equation, and it's a cubic. Normally, these cubics will have one real root, so if we go something like could be up and down and up again, so we're looking for two complex roots in this part. So z2 is going to be a conjugate root, which will be 1 plus 2i. All these complex linear equations are written as z squared minus z times the sum of the roots. You may have seen other videos on this, plus the product of the roots. It's a nice easy way to solve these questions. Equals not full stop. Let's look at the sum here. So the sum is 1 plus 2i and 1 minus 2i. So the sum is 2. The product, and this is like the difference of two squares. You see the product here is going to be 1 minus 4i squared, which is 1 plus 4, which is 5. So I have my linear z squared minus 2z plus 5 equals 0. This is my complex linear equation, or complex quadratic equation, not linear. My quadratics are written like this. So if I divide my quadratic into my cubic, I'll get my linear, which is what I was thinking of when I'm saying the incorrect information to you. So z squared minus 2z plus 5. What was the first and last term of my cubic? Let's write it down. 2z cubed minus 7z squared. 2z cubed minus 7z squared plus 16z minus 15. So my last term here and my first term here, and we'll be able to get the linear part of this cubic. So have to have a 2z to get 2z cubed. That's going to give me minus 4z and plus minus 4z squared and plus 10z. How many z squared do I want? Minus 7. So I need another minus 3z squared. So that would have to be a minus 3 to go there, and actually that finishes it off. I don't need any more information inside the box, but I can put it in. Just double check. Minus 3 by 2z minus plus 6z, which is my 16z here. So my linear part of this is 2z minus 3. Let it equal 0. We can say 2z equals 3. So z is equal to 3 over 2. So I have my three roots. Z is equal to 3 over 2. We call it z3. We call z2 1 plus 2i, and the first root we were given, z1, 1 minus 2i. Part B of this question, let w equals z1 by the conjugate of z1, and it tells you this if you don't know that z1 with a line over it is the conjugate. Plot z1, this conjugate of z1, and w on the argand diagram. We've actually multiplied z1 by the conjugate of itself up above, and here they are here, the two of them. So 1 plus z, 1 plus 2i by 1 minus 2i again from above is 1 minus 4i squared, which is 1 plus 4, which is 5. So w is equal to 5. And given it two parts, and for complex numbers we say 5 plus 0i. So if we want to do a argand diagram, you're going to do this to scale, but I'm just going to call this 5, 1 and 2. So I've got 1 plus 2i minus 2, 1 minus 2i, and I'm just going to connect these together, because in the next part we're looking for the angle inside the triangle. So this, and you're asked to label each point, so be careful to label each point. So z1 is 1 minus 2i. The conjugate of z1 is 1 plus 2i, and we have w. B part 2, find the measure of the acute angle, the conjugate of z1, w, z1, so it's this angle here. Now, if we just take the top triangle on its own, we have a right angle triangle, and then we can just double the angle. So we have a 2 here, up 2, and well, we're starting at 1 here, so this is actually a 4, it's because it goes out to 5. So if we just draw that triangle down here, we've got a 2 and a 4. We call this the angle A. So we can say we have the two straight sides, so the tan of A is 2 over 4, which is a half. So the inverse tan of 1 over 2 is going to give me, on a calculator, 26.57. I should have wrote this the nearest degree here. So take 2 decimals, 26.57. And if I multiply that by 2, I'm going to get 52 and 1.14. So 53.14. So 53 degrees to the nearest degree.